Okay, so this is going to be our first video of Unit 3 Day 2. In this first short video, we're just going to talk about algebraic inverses and how to solve one variable equations, real simple ones, right? So first thing we're looking at is, well, what are algebraic inverses? So the first thing I ask you here, what's the inverse of adding? Well, the inverse of adding is subtraction, and the inverse of subtraction, of course, is to add, right? So simple enough. Okay, then on to the second question. Well, what's the inverse of multiplying and dividing? Well, the arithmetical inverse of multiplying and dividing, well, they're inverses of one another, just like addition and subtraction are, right? So that brings us to solving equations, right? So we've been over this before at the beginning of the year, and we've continued to work on algebra. But again, this is a math refresher. That's the whole point of this uh, first couple lessons in this unit. So here we've got some equations, and we're obviously going to use algebraic inverses to solve them. So looking at this first one, 2 plus x equals negative 1. Okay, so like I tell you, we always want to start from the outside in, right? So what is making this variable we're looking for not quote unquote by itself? And the answer to that is this 2. Well, what's happening between this 2 and the x? Well, they're being added to one another. This x is positive, this 2 is positive, they're being combined, right? The inverse of a positive 2 is to subtract 2 or a minus 2, right? And what we do to one side, we do to the other because, this is an equal sign here. We have to keep it balanced. So 2 minus 2, that cancels into a 0. Negative 1 minus 2, well, that's negative 3. Our solution is negative 3. And of course, we see if we plug this back in and say 2 plus negative 3x, right, equals negative 1, well, we see that that's a true statement. 2 plus negative 3 is, in fact, negative 1. So let's look at a few more examples. So let's look at the next one. 7 equals 4 minus x. Okay, so here, same idea. We're looking for this variable x, but we see that there's two things making it not by itself, namely the negative and this positive 4 here, right? And again, like I tell you, we work from the outside in. Another way to think of it is doing the order of operations in reverse. Doing PEMDAS or GEMDAS, however you were taught it, backwards, right? So if we're looking at it backwards, well, we want to start here with addition subtraction first, right? So this positive 4 is an instance of addition, or we look at it as the furthest away from x. Either way, we start with the positive 4, whose inverse is minus 4. When we do to one side, we do the other. And remember, this x is negative. Okay, so we have to bring that negative with us. So now we've got 3 equals negative x. Well, now in PEMDAS going in reverse, we're at multiplication division. This negative x is the same thing as a negative 1 times x, right? Now, the simplest way to cancel, quote unquote, or undo a negative, right, is to just multiply by negative 1. Okay, that makes this negative x become a positive x because a negative times a negative is a positive. And what we do to one side, we of course do to the other. And there we have it. Our answer here is negative 3 also. Okay, next problem. Oops, did not mean to do that. Negative 3x equals negative 9. Okay, so there's only one thing making the x not by itself, and that's the multiplication by this negative 3, whose inverse is to divide by negative 3. Right? Anytime you're multiplying, its inverse is to divide by the exact same number. So if this is a negative 3, you're going to divide by a negative 3. Okay, so this is gone, leaving us with just x. And negative 9 divided by negative 3 is just positive 3. Okay, continuing to move on. 2x minus 4 equals negative 16. From the outside in, or doing PEMDAS in reverse, either way, we start with the minus 4, whose inverse is plus 4. What you do to one side, you do to the other. Then we divide by 2 on both sides. X is obviously 6. And let's keep getting a little bit more and more complicated here. Next example, 20 equals x over negative 5. Okay, the inverse of dividing by negative 5 is to multiply by that exact same number. And what you do to one side, you do to the other. So we get negative 100 equals x. And now we're turning it up even more complicated here. Okay, so 10 is equal to negative 5 times x over 3 minus 8. Okay, again, from the outside in, or PEMDAS in reverse. Either way, we're going to start with this minus 8, whose inverse is plus 8. We have 18 equals negative 5x over 3. Okay, then let's get rid of this division by 3, which is going to be the simplest thing to do. Okay, so multiply by 3 on both sides. We get 54 equals negative 5x. Divide by 5, well, negative 5 on both sides. And we see that x is 54 over negative 5, or negative 54 over 5. We can't simplify that any further, right? 5 does not go into 54, because 54 doesn't end in a 0 or a 5. Okay, 2 more examples. Now these are interesting because, well, you'll see here in a second. So I've got x squared equals 16. You haven't seen this since Algebra 1. X squared equals 16. Well, what is the inverse now of squaring something? Well, we know that from our use of the Pythagorean theorem. We know we're going to take the square root of both sides. So x is equal to the square root of 16, right? Now, our first instinct tells us that, well, x is only equal to 4. But that's not true. X is equal to positive or negative 4. So we say x is plus or minus 4. This is because 4 squared, positive 4 squared, equals 16, but so too does negative 4 all squared like that. Okay? You have to remember, negative 4 times itself, right? A negative times a negative gives us a positive 16 like that. So there's 2 solutions. These kinds of equations where we've got a second degree term for x, these kind of equations are called quadratics, and they always have 2 solutions. Okay, that's going to be important going forward. Okay, last one. So we've gotten pretty dang complicated here. So 37 equals x squared over 3 plus 10. Okay, nothing really changes though. We're doing order of operations in reverse, or we are working from the outside in. So minus 10 to both sides, times 3 on both sides. Take the square root of both sides. And we see that x is plus or minus 9. Okay, and just to double check, because that is kind of complicated, let's try it and make sure it works. So let's take the original equation and plug in for x. First using positive 9. So let's say 37 equals positive 9 squared over 3 plus 10. Okay, 9 squared is 81. Over 3 is 27. Plus 10 is 37. Hey, it worked. Okay, now let's try it with negative 9. Okay, so 37 is equal to, always use parentheses, negative 9 squared, right? Because it's negative 9 itself, all squared, over 3 plus 10. So we're going to square negative 9, and we get positive 81 over 3. And we see that we have the exact same equation from earlier, which means we're just going to go to this and then go to this, of course. Okay, so we know it works. So that concludes this little video on solving one variable equations. Goodbye.